All right, so now we're going to talk about geometric series. And so we'll sort of start with the simplest of all geometric series, call it S. And we're going to start with the number 1, and then we're just going to keep multiplying by x. And so that x would, in this case, often be called the common ratio. So I'm adding up x, and then x squared, and then x cubed, and x to the 4th, and so on. We'll continue this forever. It's an infinite geometric series. And so using our sigma notation, it's a relatively simple pattern. It's just powers of x. We're starting at x to the 0, right? Because x to the 0 is 1, and we're just going forever. And so you may remember working on things like this in previous math classes. This is sort of the simplest one, and we'll see what happens when we get into some other ones in a little bit. And so if I want to figure out this sum, there's a nifty little trick that you can do. And so I'm going to take this whole formula and I'm going to multiply by x. And so I have to distribute this x through the infinite thing. And so the 1, when I multiply by x, becomes x. The x becomes x squared. The x squared becomes x cubed, and so on. And so I get the same thing that I had before, except the 1 has now turned into an x, right? And it still keeps going on forever. So it's still that dot, dot, dot at the end. Well, here's the nifty trick, right? I can now subtract these two lines. And so when I subtract these two lines, on the left I get s minus x times s. And on the right, almost as if by magic, everything disappears, and I just get 1 left. And so if I'm curious what s is, I'm going to factor it out and then divide. So I get s equals 1 over 1 minus x. And so this is our first example of what's called a power series. And so these things are considered to be equal. They're exactly the same thing. So I can write it with sigma notation out here. And this is actually something that you'll be expected to have memorized. And so if I want to think about what 1 over 1 minus x equals, it's equal to this infinite sum, and vice versa. This infinite sum is equal to 1 over 1 minus x. Now there's a big catch, right? And that is for geometric series to converge, for it actually to work, these things that we're adding up have to be getting smaller, right? And in order for these things to be getting smaller, I have to have started with a number that was less than 1. If you start with 1, you'll just keep getting 1s. If you start with a number that's bigger than 1, the number will just keep getting bigger, and it will diverge. As we know that new word, it would just keep getting bigger and bigger and bigger. And so we're going to put this big if here, right? These two things are equal as long as x is less than 1, and the other thing we have to take into account is negatives. And so I'm actually going to say if the absolute value of x is less than 1, which is equivalent to saying if x is between 1 and negative 1. Notice, importantly here, right, there's no equal bar under here. So it's strictly less than 1, strictly greater than negative 1. It has to be in between those two things. If that's the case, then this geometric series is exactly equal to 1 over 1 minus x. And so this is sort of cool, right? We can sort of transfer between this rational function and this infinite series as we want or need to. And that also lets me create some other series relationships fairly easily. And so let's say that I came across this series. So 8 plus 8x plus 8x squared plus 8x cubed, and so on. And I was interested in what this series is equal to. Well, of course, all this has is this extra 8. And so I factor out the 8, right? It was 8 all the way along. And now I have this memorized. I know that this thing in parentheses is my friend from earlier. It's 1 over 1 minus x. And so this infinite series that I started with would just be 8 over 1 minus x, right? And we would want to make note of when this is going to converge. Well, the 8 is just sitting out here. It's still going to converge at that same place, and so still converging if the absolute value of x is less than 1. And so we can start with a series and sort of manipulate it a little bit. So here would be another 1. So maybe this time I do have 1 again. But then I have 4x. And then I have 4x quantity squared. And then 4x quantity cubed. And so notice this time, of course, the big difference from the last one is on the last one, the 8 was not in the parentheses, right? And so I was able to factor that 8 out. This time, the 4 is in with the x, and so that's sort of my multiplier. And so now when I switch to the formula, the 1 is still here, right? And now my multiplier is 4x, right? And so that takes the spot of the x in my original formula, right? And so instead of having x's all the way along here, I have 4 x's, and so I put 4x down there. And now I have to think about how this is going to work, or when this is going to work. Well, it's going to work if that thing I'm multiplying by, which in this case is 4x, has an absolute value less than 1. And so if I want to clean that up, it's only going to work when the absolute value is less than 1/4.